No signal? Well, it has to be one of them. No signal? Well, then it has to be the last one.
Maybe it's just the phone itself, and it should be on HDMI, maybe.
This is why the other teacher didn't want to use this one. The projector I normally use, the other teacher took it. I understand why now, maybe. Oh, we're in business. Great. Okay. Okay. I know it's not great, but I'm going to have slides up there so it can be nice and clear. Right. No, I want to turn my pad on. Great. Now we got pen. We do. So now we just need notes. Everybody have paper? Yeah?
Yes.
Okay. So anyways, as I was saying, there's 6 parts to the course. I was going to do 2 lessons today, but I was thinking, it's your first lesson, maybe we'll go a bit slowly. But usually we do 2 topics in 2 hours, but maybe since it's your first day, we'll go a little slower. The 6 parts are mechanics, electricity, materials, waves, fields, and atoms. They're the 6 parts, yeah? Now the biggest part is mechanics, yes, and in fact this is the first part of the course. It's also maybe, for some people, very difficult because of all the English in it, for the mechanics, you know. It depends on who you ask, yeah. So for the mechanics we have 23 topics to do, which is the biggest topic. So this will take us until the midterm holiday to complete. Yeah.
Because that it's you mean that it's hard?
I don't think it's hard if you do your studies. So what will probably happen is we'll probably do this for 5 weeks. We have our 1 week holiday, and then when we come back for the other 5 weeks, then we do electricity, which is smaller, and materials, which is also smaller.
You mean that we have a 1 week holiday?
In 5 weeks. Yeah. And then after this 1 week holiday, you'll have a small test in the class on mechanics.
Mechanics?
Yeah, because that's what we'll have done for 5 weeks.
Like today we will have mechanics now.
Yeah, for 5 weeks.
And now we will have mechanics.
Yes, we will. And then for the next 5 weeks, also mechanics.
Because I don't know which section of engineering I want to enter, like for airplane.
Oh yes. Well, hopefully by the end you'll know. Yes. Okay. So, anyways, I keep forgetting that you didn't have the induction last week, so I don't know if you know everything with the way things are done. But all these lessons are recorded. So right now this is being recorded. Okay. Now, don't let that be a problem for you. The microphone on this is really, really low quality, so it'll only pick up my voice because I'm talking loudly and I'm beside it. If you ask me a question, you probably won't hear it on the video. As you watch the video, you'll hear me talking, and then you'll hear in the background, and I'll say, good question. So it's not great sound quality, okay? But everything's been recorded. So this is our first lesson, units and dimensions, and I think we'll just do this one today, unless you're so smart we get it done really quickly. But all you need for this is pen and paper, okay? And anything else you need to know before you start? Yeah, the only other thing to say is every lesson you get homework, and I put homework on Moodle. So before we finish today, we'll make sure you can log into Moodle. Now, does everybody have a smartphone?
Yes.
Yeah. There's Wi-Fi. Do you have a smartphone? Yeah, of course you do. Yeah. There's Wi-Fi in this room. I will check it later at the end when we're doing the homework. But we can just check that we can log in. Now you can't log in because I didn't make your account because I only knew about you today. Yeah. So I made your account last week. Oh no, don't worry. I'll take care of them for later. I'll make your account before I go home. Okay, so write this down. So this is the first lesson, units and dimensions then. We'll explain everything about this now. Now, part of what you will need to learn is making notes. So there will be many slides. You don't need to write down everything on every slide. You need to understand what are the key pieces of information. Can we start? Yeah? Sure. Okay, so again, this is an example of what you don't need to write down. So in this lesson, we're going to have a look at physical quantities, the SI units, and prefixes. And these are things you might already know. Okay, so a unit is a reference system used to measure a physical quantity. So again, you don't need to write this down just yet. Length, mass, and time are called fundamental dimensions. Right, so the two things we have so far, a unit is what you use to measure something.
That's like centimeters.
Like centimeters, meters, and all that. But don't mix that up with dimension. Length, mass, and time are called dimensions. So unit measures, a dimension. There's a small difference between the two. So you might want to write down what are the fundamental dimensions. They're length, mass, and time. Okay. You all know length, of course. Length is how long. Time, you all know as well. And mass, mass, like this, kilograms is the unit used to measure mass. So the three fundamental dimensions are length, mass, and time. Now, what do you think it means to say they're fundamental dimensions?
These are the basic, and then
that's it. There's a basic, and we build on them. Okay, so for example, the meter is used to measure length, and length is a dimension. Other dimensions can be created from these three. So, for example, area is length squared. The size of a unit, the size or how much of a unit is present is called the magnitude. So you might want to write that down. Magnitude means how much, the size.
Like magnitude, like the size, how much of the unit is present is the magnitude, yes?
Yeah, so what does that mean? It means, like, if I said, what's the magnitude of the measurement? It means how big is the measurement? How large? Yeah. How big is it? Yeah. So you can think about it like this. Magnitude is a noun. And it's like the noun for the question, how much. So if I said how much, it's like saying, what is the magnitude? Okay, you got that?
One second.
Yes. Okay. By the way, if you miss something, you can always watch the video at home, because the video will be everything you see on the screen. YouTube channel, the link for the YouTube channel is on Moodle. I'll give you the username and password later. Okay. Continue?
Yes.
Okay. So, no Americans, everybody here is different nationalities. We have Korean, Chinese, Sudanese, Egyptian, Sudanese, Pakistani, Iraqi. So in all your countries, you use the international system of units. Yes. If you're not American, you use this one. So the international system, of course, we also use in Europe and the rest of the world. So we have basic units in the international system of units. It's worldwide units, and it's used in science and business, and there's 7 basic units. It's called the 7 base units. Yeah. So what are those 7? So of course, you'll need to write these 7 down. So the first one, well, give me one of them.
Length.
Yeah, so the meter is the first one.
Yes.
And the meter is used to measure
Length.
the dimension of length. Correct, yes, sir. Okay, I want to write that down. Does anybody know which country the international system of units, the metric system, started? In which country? Do you know which was the first country to use it? No.
UK?
Oh no.
There was
Definitely
another
not.
system, EDF for that.
Yes. They still use it. No, nobody knows the first country to use this.
No, can I
No.
guess?
What do you think? It's not Ireland.
Germany?
No. Good guess though. It would make sense. But it's France. France. Yeah, this is France. This is where all these units came from. You didn't know this? No. No. So it was the French that created these units that are used globally. Yeah. Okay, so the meter is the first one. What else do we have?
Kilogram, kg.
Very good. The kilogram kg, which measures the dimension of mass. Yeah. Okay, next one.
Time.
Time, yeah. So what unit is time?
Second.
Seconds, yeah. So the second S, which measures the dimension of time. Okay, got that? Yeah. Right, well there's the 3 ones that everybody would know from day-to-day life. Do we know any more?
Intensity.
Yes, what type?
Candle, I think.
Yes, that one's later, yeah. Maybe something easier first. But you're right, that's one of them. The next one is amp. And what does amp measure?
Current.
It's to do with electricity, yeah, it's the current. Yeah, so it measures electrical current. Yeah. And we'll look at that later when we do electricity, not really for now.
But not now?
Well, I mean, you need to write it down, but I'm saying we'll talk about that one
Later.
later, yeah. Okay. We've got that as well. So, the next one, not that one, no. The next one is the Kelvin.
Yeah, Kelvin, like...
Temperature.
Yes.
Yeah. Measures the dimension of temperature. We use this symbol for that dimension. Okay, so far that's 5 of them, 2 left. The next one is the mole.
Mole, that's a measure.
That's an amount.
Amount, yes, substance. So the mole, which measures the dimension of, what would we call it? Substance good, yeah, or amount or something like this. Amount of substance, yeah.
Or the measure.
Amount, I think, in English is a little bit more accurate word. Mostly used in chemistry, the mole. And the last one is the one you mentioned earlier. Do you remember its name?
Which intensity?
Yeah. What's the unit called?
Candela.
Yeah. That's it. So the last unit is called the candela, or CD for short. This is a unit which we will not use on this course.
In the next semester?
No, ever. Yeah. So we don't use this unit, but it's one of the basic units. And as you said, it measures the dimension of luminous intensity, or brightness. It's a very unusual unit. Very unusual unit. And the first 6 units exist even if humans didn't exist. A meter is still a meter even if people didn't exist. Whereas the last one, the candela, is brightness, but I think it requires humans for the definition, because it is... Yeah, it's like the definition is it appears this bright to this particular person. Like in the definition it requires a person to be part of the definition. Whereas the other 6 don't need people. A kilogram's a kilogram, a meter is a meter. But the last one uses humans or people as part of the definition. So it's a very strange unit. It's a very strange unit. It's not one that we use in this course. A candela is measurement of how we see the brightness of light. So it's a human perception.
So a reflection?
It's more like brightness to your eye. But again, my point is to your eye.
Yeah.
So this is why a person is required in the definition. So it's a weird unit. Okay, anyways, it's not one we use. The other 6 we use in this class. Continue?
Yeah.
Which one are you writing down?
Last one.
Oh, okay. The other 6 everybody's used before. Has anyone used the last one?
No.
No. You've used it,
Never.
yeah? In college? Huh? Yes, okay, yeah. What type of problem?
Maybe television, but I don't know.
It's a television. How
to make television and that.
Oh, okay, yes. The brightness from the television, yeah. Yes, and that would be an important unit for it, because people are looking at the television. Okay, next now. So, quantities of the same dimension may be compared or equated. So, for example, you could have something like, here this could be 5 kilograms, and you could say, well, that's less than 6 kilograms, because they're the same dimension of mass. You can compare them. Or if it was 5, then you could say they're equal. Yeah. So if they're the same dimension, you can compare or equate them. If they have the same dimension, you can add, subtract, multiply, or divide them. If they're different dimensions, you cannot add or subtract them. So you cannot do 5 kilograms plus 2 meters. Yeah, it's ridiculous. You can't do that.
Like different measures.
Different measures cannot combine. This way.
If it's same measure, but different numbers, you can.
Yes, same dimension, you can. You cannot add or subtract them. But if they're different, you can still multiply or divide them, which might seem odd. So for example, 5 kilograms plus 2 meters, well, that's a big no. Can it be done?
Yes.
But 5 kilograms multiply
By
2 meters, that's equal to 10 kilogram meters.
Yes. Okay.
And this is okay,
This is
allowed.
allowed.
Yes, yes. So, in other words, multiply and divide, whatever. Plus and minus, only same dimensions are possible.
But different measures, like plus and
Mhm.
minus, it's round, yes?
No, you could add or plus or
No,
minus.
like 5 kilogram.
Yes, it's
plus-
wrong. You can't do
plus
this.
2 meter, it's wrong.
It's very wrong.
Or
Yes.
or minus.
Or minus, yes, plus or minus, yeah. Now, you don't need to write that down if you knew that. I think you probably knew that already, yeah. Okay, so here are some examples, we'll do them together, so I don't need to write anything down. Which are valid and which are invalid. So, 5 meters plus 2 meters, that's valid, of course. 5 meters is bigger than 2 meters, of course that's valid. 2 hours is bigger than 1 kilogram,
No.
that's not valid. X is 3 kilograms divided by 2 meters cubed, is valid. And then 5 meters plus 2 kilograms, not valid. And lastly, 5 meters times 2 kilograms is valid. So that's okay. Here are some more to try. Let's see. I think. Yes. Okay. Now we're going to get a bit more interesting now. So in this question, maybe I'll let you try it first and see how you do. Actually, the only thing I tell you is that X measures length and M measures mass. That's all I tell you, okay? And that's enough. I want you to tell me, you can write it down, what each of these dimensions are. What's the dimension, okay? And the only information you have is that X is for length and M is for mass, okay? So try these and we'll see how we do, then I'll do them. Yeah, so you can write these down in your book.
That's dimension for M.
Maybe I'll do the first one just to get you started. Give me a little bit. What dimension is W? Does anyone know? What dimension is W?
Is it what?
W.
Nope.
Wait.
Nope.
Wait,
No, you're all guessing. You're guessing. Think. You can only use what I told you.
Width.
No.
Width.
No.
With
No.
Wavelength?
Oh my goodness. You're guessing. No. Stop. Clear your mind. Okay. So W equals X plus Y plus Z. Now, just yes or no. Did I tell you what Z is? No. Did I tell you Y? No. Did I tell you W? No. Did I tell you X? Yes. What dimension is length? Right. Now, if these are being added together, they must also be length, otherwise it doesn't make sense. And if you add 3 lengths together, the result is also a length. So this must be dimension length. Yeah, okay, so think, okay? Right, so try, now that you have the idea, try the next ones, okay? You can write them down. And the questions are linked, so you can use the previous answer for the next part if it helps. Got them, yeah? Okay. Let me have a look now. Okay, so the next one is A equals xy. And what's the dimension of A?
L square.
L
Square.
squared.
Yeah.
Yeah, because we know from the previous one that x is length.
Uh-huh.
And y is length.
Yeah.
So that says not the new one. it's the-
Yeah, I said they're linked, yes.
So y is
So
so
it's
y
L.
is L.
Y is also L from part A.
Okay.
So it's length squared, yeah. Now what was my next one? Let me see. It was V, yeah, okay. So V equals x, y, z. So V must be measured in, dimension is length cubed. Yeah, now that's also fine. And the last one is rho equals, M over V. Now we know that the top one is mass, the top one, yeah. And the bottom one is L cubed. So the unit would be, the dimension would be mass per length cubed, yeah, or I prefer to write it like this, mass length minus 3. Prefer. So,
Like from divide to multiply.
yeah, to make it the minus power, it's more normal, more usual. So,
Or
mass per
easy,
length
easy,
cubed. Oh, this is what we use. Yeah. Yeah, we'll talk about that in a minute too. Okay, you have that?
Yeah.
Yeah. We're getting the idea now, yeah? Yeah. Okay. Continue. Right, so the same questions again, but this time what's the unit? So I think we'll just say, you can write the answer beside your previous answer. So the first answer we said the W's unit or dimension was length. So the unit will be meter.
Yes.
The second one,
Mm.
meter squared. The third one, meter cubed. And the last one,
meter per length cube.
meter per
meter
meter
cube.
cube.
kg
No.
per meter cube.
kg per meter cubed. Yes, kg per meter cubed. Yeah. So kg. So if you want to know what that looks like, the last one is kg per meter cubed. So like this then. Yeah. Okay. So that's all okay. That's basic enough. Right, yeah.
It doesn't matter with the letters if it's L, X, minus 3.
What do you mean it doesn't matter?
Like here, like M, L, power minus 3.
Yes.
So it doesn't matter if it's like A, B.
No, in fact, the letters that I'm using are normal letters to use. So when somebody says dimension of length, they usually write it as an L.
Okay.
Yeah. So yeah, it does actually matter. Yeah. And temperature, dimension of temperature is written like this. Yeah, theta. Yeah. Okay. So this is our first. So far, it's basic enough.
Yeah.
So this is our first definition, which continues kind of from the last question. So the last one actually you might remember from school. Density. Density measures mass per volume. And the formula would be density is mass divided by volume.
B equal M over V.
Yeah, actually I should really make that a big V.
Yeah, because
Yeah.
small v is
But
for
velocity, yeah. What's the unit here? Well, that was mass per,
kg per
kilogram per meter cubed.
Meter cube.
And the dimension is mass per length cubed. So the dimension is mass per length cubed, or we should really write it like this, ml minus 3, with units of kg per meter cubed, or really should be kg minus 3 is how we should write it. So you'll need to write all of this definition down. In the exam, sometimes they ask you for definitions, but I think this is a definition everybody, well, maybe everyone remembers, maybe not from high school or from college. This is a Greek letter. How do we pronounce this Greek letter? Rho, yeah.
Rho.
Yeah. It's a Greek letter, yeah. Like alpha, beta, gamma. Everybody knows all their Greek letters?
Most of them.
Most of them, yeah.
Most of them.
Yeah. What's alpha, beta, gamma, delta? What's next? Epsilon?
Yes.
The E, yes, yes.
And then there are
Yeah.
lambda.
Lambda, mu, theta,
Mu,
omega, iota, eta, yes, kappa.
And the one, sir, what's this?
Sigma.
Sigma.
Sigma, yes. Okay, we have this, yeah.
Then
Yeah. That's okay?
Yeah.
Okay. So this is density. In fact, really, you learn about density in middle school, I think. Really, middle school, yeah. Except maybe in middle school your teacher wasn't so particular about the dimension, but of course you would have learned about the unit. Okay, so that's density, our first definition. So remember earlier we were saying that we have three fundamental dimensions: mass, length and time. So all of our all of our new dimensions can come from these three. So like density's dimension is again using mass and length. Okay. So we and I shall try not to use the forward slash. Okay, this is not the way we use it nowadays. So we'll try not to use this. Now you can still use it, it's still okay to use. And in fact, I feel like outside of physics it's more normal to use the forward slash. You know, so like for example, if you're looking on the motorway, the speed limit will be 120 kilometers per hour. It won't say km, HR minus 1. Okay, it won't say this. So the forward slash is still okay outside of physics class, but in physics class we try to keep it like this. Okay. But I don't want you thinking that this is wrong. It's not wrong, it's just not what we use. Okay. So here's a question now. I think I'll let you try this to see what you do. Yeah. So what is the density of 1 litre of water? It has a mass of 1 kilogram and 1,000 litres makes up 1 metre cubed. I want to just see how you try this one, and we'll do it together. What I really want you to be careful about is that in the formula you need to divide by the volume. And litres we do not use in physics to measure volume. Litres is maybe what you might use in chemistry to measure volume. So you're going to need to convert litres into metre cubed. And I tell you that 1,000 litres makes 1 metre cubed. Try it anyways, I'll do it in a minute. See, I want to see what you can do here. Yeah? Yeah. Let's see. What's the unit?
What unit?
Yeah.
This unit will be kg, kg meter per
kg per meter cubed.
Yeah.
Yeah, we'll do it together now, just to make sure. Really, for this question, it's just practicing about using your unit. So, for example, the density equals the mass over the volume. Now, what do I tell you in the question? I tell you you have 1 litre and it's 1 kilogram. Okay, so the mass we know is 1 kilogram. The volume we don't know, or really we do know, but it's not the unit we want. It's in litres. We have 1 litre. So you can see the problem is here. This is the problem. Now, we do know that 1,000 litres is 1 metre cubed. So that means 1 litre is 1 over 1,000 metres cubed. And this is the key. I can use that to replace my problem.
So one over 1,000.
Yeah, 1 over 1,000. It'll be 1 kilogram over 1 over 1,000 meters cubed. Now it's good. This will equal 1,000 kilograms
But
per
it will
meter
be-
cubed.
But it will be 1,000 meter minus 3.
Yeah, that is there. Yeah. So this is the correct answer now. The answer is 1,000 kilograms per meter cubed. Liters will be used more in chemistry class. Okay, so whenever we see liters in physics, we must convert it to meters cubed. We must. Okay. Okay, so that was just a warm-up question here. We'll continue. Yeah. Okay, so we don't always deal with meters and seconds and so on. We can make them bigger or smaller using what's called a prefix. Now you know prefixes from English, so you know you can be.
Yes.
Yeah, give me an example of a prefix from English. Give me an English prefix.
Untidy.
Yeah, tidy, untidy.
Yes.
Yeah. Dis, yeah.
Dirty,
Respect,
clean.
disrespectful or something.
Dirty, clean.
No, prefix meaning you put something at the front of the word to change its meaning. Yeah. So happy, unhappy. Healthy, unhealthy. Yeah. Valid, invalid. Yeah.
Similar.
Yes, similar, and so on. So we have prefixes like on, in, this, and so on. We have prefixes in physics as well, and the prefixes change the size. So, for example, you have meter, and then kilometer, gram, and kilogram. So these are prefixes.
This will change the...
It changes the size, yeah. Now, for example, 1 kilogram is 1,000 grams, 1 kilometer is 1,000 meters, 100 centimeters is 1 meter. So, the prefixes which you will need to learn, absolutely must remember and must know for physics are. Now, there's no choice, you must know these ones. These are the minimum to know. So the first one we'll start off with is giga. Now, if you think about your hard drive, you might figure out what giga is. Giga is how big? How many zeros? 9, 10, 12, something like these?
Yes.
12.
We're setting for 12? 9. 12 is tera. Tera is 12, yeah. So it's 9 zeros. Yeah. Yes.
I know number 6.
Yeah.
I don't remember the...
I think you might. If you think about your hard drive, what's the next one? Before giga.
Giga.
No, before. Smaller.
Number...
M is called... mega. You know this. Mega M is 6. Yes, a million. Okay, so write these down, please, as we go along. So we have a mega, 1,000 megas make a giga, 1,000 gigas make a tera, and so on. Okay, what is before mega?
Number...
K.
Kelvin.
No, kilo. Kilo. Small k.
Number 3.
3, yeah. 1,000, like kilometer, kilogram.
Yeah.
Small k, because big K is Kelvin.
Yeah.
Okay. Centile. Well, I should have asked, but centile.
It's the number 1.
No.
Then minus, it comes to
Minus
3.
9.
Minus
No.
3.
Minus
No.
9.
Minus 2 or minus
Minus, well, wait, think for a second, which is it? Minus 2 or minus 3?
Minus 2.
Minus 2.
Minus 2.
Centi C is minus 2 because there's 100 centimeters in a meter. Yeah, so it's 100, so minus 2, 0.01.
Small c.
Small c, yeah. Centai. Okay. What's before centai? Milli. Yeah. Which is a small m. And its size?
10 minus 3.
10 minus 3 is milli. Yeah. Okay. And you know this one too. Millimeter. Yeah. Milligram as well. Okay. What's before milli?
Micro.
Oh, we don't use that one, so go to the next one.
Micro.
Yeah, micro. What letter is that?
It's like mu.
Mu. Yeah. And its size?
10 minus 6.
10 minus 9.
10 power minus 6.
Minus 6.
Yeah. Yeah. Micrometer, microgram, things like this. Okay, we do one more. Nano.
This is minus 9.
This is minus 9. The letter is N. 10 to the minus 9. 9 zeros. Yep. Yes, yeah. Okay. Right. Continue, you got all those? Yeah. Right, so these are our prefixes, but I think most of them you've seen before anyways. Okay, so we'll have a practice now. I'll do this one, practice using prefixes. So you can just write the question down and I'll do it together. We'll do it together. So convert 50 kilometers per hour into meters per second. Okay, so I want to show you the right way of doing this. I mean, you would have learned some way of doing this in high school, or college, or middle school, or whatever. But it's maybe not the right way. Or, no, sorry, maybe not the best way. It's right if you get the right answer. Okay, can we have a look at this? Yep, let's do it now. So, okay, this is this example, I just want to show you the way you should write this answer out. So, for example, if I said 50 kilometers per hour, you can write that as 50 kilometers per hour above 1 hour. So this is, or if you want to be even clearer, 50 kilometers over 1 hour. Now, this is where you should put in the prefix values. So 50, and this K here has a value of 1,000. Yeah, so this is 1,000 meters. And an hour, 3,600 seconds. Now we have the units we want. Okay, so I don't have my calculator.
180 multiplied by 10 raised to the power 6.
I don't know, that sounds awfully small.
No, round it off.
Yeah, but you got minus 6?
No, 10 power 6.
That sounds awfully big. Try again.
I got it 13.8.
That sounds more like it.
13.88.
13.8. So 13.9 meters per second.
So you round it 9?
13.9.
Oh yeah, we'll talk about that too, yeah.
Okay.
So in physics, for our final answer, we usually use 3 significant figures. So look, we have 1, 2, 3. 3 is the usual. Sometimes 4, usually 3. 3 numbers.
No, but in our course,
Yeah.
we use the 3 significant figures after the decimal. It's 13, then we can use up to 3. We can use 0.888. But if
You use 3 decimal places.
Yeah.
In maths class, we'll talk about that, and that's fine. That's fine. I'm only telling you the minimum for the
Okay.
exam. So the
Right.
minimum for the exam is they want at least 3.
yes,
Yeah.
but if we round it off, it becomes 13.9, and it's the best close answer.
Yeah, that's fine. Yeah, and in the exam, as long as you don't say 14, then you're okay. More is better. If you give me more, that's fine. Okay, so that's basic example. Now this one is a little trickier. I want you to try it,
Okay.
and we'll see if you get it right.
Maybe 0.5.
Maybe, maybe not. I'll give you the answer in a minute. If you finish, you can just put a box around it. You know what to do? Can you think you can do this one? Maybe, maybe not. Anyone else? No?
I'm stuck on that one. I'm sure it's
So it will be like 5.0.
no, it's
You think you also went with 0.5?
No, I don't think it's true. I don't think it's right because
I got
the power
like 5.0.
Yeah.
and
Something. Andy?
0.5.
Oh.
Not 0.5.
No?
powerhouse.
No. All right, let's do it. So I tricked you a tiny bit. Please note, in physics, when we write cm squared,
yes.
that's like cm. Yeah. Or if you prefer cm squared like this. Now, please be careful. In math class, when I write this, I do not mean this.
Yeah.
yes,
In math class.
power on the wire.
Yes. So we're good with that.
Yes.
Okay, good. Right. So again, do it the way I showed you the first example. 50 centimeters squared. That's equal to 50 cm squared. That's equal to 50, and what's the value of centi? 0.01 meters squared. That's 50, 0.01 squared meters squared.
5 minus 3.
50, 0.0001 meters squared.
Okay, why
Yeah.
it's 0.0001?
I squared it, the square.
Okay.
Yeah. Now, and 50 times this one as well. So let me see. Yes, I'll have to move that in my head as well. So the decimal point here, and we have to move it 4 times. 1, 2, 3, 4. 0.005 meter squared.
5 multiplied by 10 minus 3.
Yeah, if you want to be a bit more scientific about it, it's 5 times 10 to the minus 3 meters squared. Which nobody got, which I didn't expect you to, because I said it was tricky. And this is what I mean. Wait, before you write down. Wait, stop. Before you write down. Do you see what I mean about the right way to do this? Okay, so the way we deal with units is like in maths. We just treat it like a thing and replace the prefix with its value. Do you get what I'm saying? Yeah. So this is the right way to do these types of problems. Okay, so since nobody got it, I want you to carefully write this example down. Okay, this is how it should look. So write this down.
Sir, could you please show me the question?
The question was, convert 50 centimeters squared into meters squared. Convert 50 centimeters squared into meters squared. Okay. Is that the way you would have seen it in high school or not? You saw how to do these some other way? Or you didn't really see how to do these problems in high school, formally?
Means we do directly. We can use the calculator in our paper.
But it wasn't successful. So this is what I mean, this is the best way to do it.
Yes,
Step by step. Yeah.
Because it was not good to do it with the calculator without understanding.
In fact, I would say it's quite bad. Yes. Yeah, this is the best way to do it. Okay, you have this?
Yes.
Yep. Okay. Sorry, can I continue or you need a minute?
No,
Yeah.
yes.
Right. Okay, so there might be time. Yeah, there's time to do the second lesson. But before doing the second lesson, I want to make sure you can log into Moodle. So if you don't have internet on your phone, you can use the Wi-Fi in this room. Do you want to see if you can pick up a Wi-Fi signal on your phone? Just have a check. There should be Wi-Fi in this room. Why don't you have a look, check?
I have a Wi-Fi in the phone.
Okay, well, if you don't want to use your data, you can use the free Wi-Fi. Is there a Wi-Fi called GHR? Yeah, yeah. And does it need a password?
Yes.
Yeah. Let's see. The password is, I think, halls of residence.
You must be knowing.
Yeah.
In the halls of residence. So you must be knowing the password.
Oh, you know the password. Yeah. This is it, isn't it?
Yeah.
Yeah. Okay. So when you connect to the internet, I want you to go to this website.
Can I?
You can connect whatever way you want to the internet. If you want to use your...
This is what?
This is the Wi-Fi password.
What? That's S, right?
Oh, sorry. This letter is I. Sorry.
This one?
Yeah.
Okay, the password
Is this.
this.
Yeah. Yeah. You connected?
Yes.
And can you go to this website?
Yeah. So after.
Okay, so I don't think this website will... Oh, well, this might work for you. When did you register, Isaac? When did you register? Did you register with Sylvia today or last week? Or? Yeah. Did you see Sylvia?
Sorry?
Did you go to the office?
Yeah.
Yeah, okay.
Not go to the office.
You need to do that. Okay.
Yeah.
So maybe this won't work for you. But anyways, you can try to log in. So your username is your email address. Now wait, before you type it in, it's the email address you gave to Sylvia for registration. Okay. Your password is your date of birth, and you must type it like this. For example, this is the 1/January/2000, for example. So
No, like the password is what?
this is the password, your date of birth.
Okay, my date of birth.
Yeah. Now the day must have two numbers. You must have a slash. You must have two numbers for the month.
Yes.
You must have a slash,
Sure.
and you must have four numbers for the year.
Okay, but the username,
Good.
About
Is your
the-
date of birth? Is your email address?
my email address,
You
username.
registered as your
Yeah.
username.
Yeah, okay.
Now, can I see your phone screen? Can you show me when you logged in? Do you have a list of your classes?
Yeah.
Yeah. So do you see physics there?
Yeah.
Great. Click physics. And you should get a list of PDF files.
Yeah.
Great. Click the first PDF.
Done.
Great. Did it open up? It's loading.
So I can't see.
You can try. It might not work. Your email address.
Okay.
Yeah.
Name space or
Perfect.
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 okay.
So it's our homework. Maybe.
Yes. Yeah. It's this. What you're looking at is this. It should be the same as that.
Okay.
Give me the email.
Yeah. That's okay.
What's your email? Surely you know your email address.
Sure, I know.
Yeah. Good. So what's the problem?
No, like I want to know only the website.
Oh, this is the website. Here. This is the address.
This one, yeah.
Yeah. Doesn't work. Okay. Does yours work to log in?
Says invalid login, please try again.
Okay.
Yeah.
You too?
Yeah, same.
I'll have to check your details. Sometimes what happens is your agent's email address is what Sylvia has on record for your email address.
The username is my name or the
Your email address.
My email, okay.
Yeah. Did you go through an agent?
Yes.
Maybe it's their email address. Did you go through an agent?
No.
No, direct application?
Yeah, I think so.
Oh, okay. You didn't, now when you type in your date of birth, do you have it 2 numbers, a slash, 2 numbers, a slash and 4 numbers?
Yes.
Yeah, okay.
Maybe it was sent to my dad's email, maybe.
We'll check it now together. Andy, yours doesn't work.
Yeah.
Amazing. Yours, check in.
1 second.
Yours. Okay. So anyways, just in case you can't log in tonight,
Oh,
can you just take a picture on your phone? This is your homework.
Yeah.
Okay?
okay, we'll do it as a paper, yes?
Do it in your notebook.
Okay.
Yeah. Yeah.
I was hoping not.
So you don't need to because you have the homework there. Yeah. Is everybody on WhatsApp? Do you have a WhatsApp group yet?
No.
No?
We don't have a WhatsApp group yet.
But you're all on WhatsApp.
Yeah.
Yeah. So maybe you want to make a physics WhatsApp group.
Yeah.
Yeah, it might be a good idea. Because that way, for example, you could share that link for the PDF, or you can send the PDF.
Okay, so tomorrow we will do the homework. So
I'll do it. I'll do it in class.
no, like tomorrow we give you the homework or what?
Oh, I'll just check it. I'll check it. You keep it in your notebook. Keep it with your notes.
Okay, so do it today and like tomorrow.
Yeah.
Like tomorrow.
Yeah, it's for our next class. Is our next class tomorrow?
I don't know.
Yes. Now, I want to try and fix the accounts for those people who are having trouble. So I think, I think what we'll do is I'll try and fix your accounts, and maybe I'll just let you start the homework now rather than do another lesson. I think we'll do 2 lessons tomorrow. But let's just stop the video so not everybody on the internet sees your username and password. Okay.